Welcome to Matematika. Today we're going to do problems and solutions of rational functions and wholes. Let's start with the first question. Find the whole of the following rational function. Question 1. F of x is equals to x squared minus 1 over x squared plus 7x minus 8. So in order to find the whole of the function, we have to factor out the numerator and the denominator. So in this case, we have x squared minus 1. This is the difference of 2 squared. So this will be x plus 1 times x minus 1. As to the denominator, we have x squared plus 7x minus 8. So we have to factor out using the value of 8 as the subject for our factors. So 8 could be factored as, because the middle term is 7, so it should be 1 and 8. Alright, so x plus 8, since our middle is positive, and x minus 1. Alright, so we can see a common factor in the numerator and in the denominator, which is x minus 1. If we equate that to 0, then x would be equals to 1. And this is the whole in the number 1. For number 2, g of x is 3x squared plus 6x over x squared plus 7x plus 10. So we factor. The common factor is 3x. And then 3x squared over 3x, that's x plus 2. Okay? 60 divided by 3, that's 2. So x squared plus 7x plus 10. 10 is all positive, so we have x plus 2 and x plus 5. Okay, we see a common factor. That would be this would be the whole in the function. So the whole here is x plus 2 equals 0. So x is equals to negative 2. That's the whole. For 3, t squared, h of t is t squared minus plus 2t minus 15. So when we factor out 15, we can have 3 and 5. The middle is positive, so 5 should be here. And 3 is negative. So we have, oh, that's not x, sorry. So this will be t plus 5 and t minus 3 over t plus 5. So we can cancel out the factor. So to find the whole is to equate that to 0. T is equals to 5. That's the whole. Negative 5, I mean. That's the whole. State the whole of the following rational function and use the limit notation. Okay, let's start with this figure right here. As I've said, you have to find where the x value is, 1, 2, 3, 4, 5. That's the location of your whole. And then as the value of x from right approaches the x equals 5, as well as from left as it approaches to the whole of where it is located at 5, then it approaches at somewhere in the location of here. 1, 2, 3, 4, 5, 6, 7. Okay? That is 7. So in other words, We can write our limit notation now. So as x approach 5 from left, the function of x is 7. The limit of x approach 5 from right, the function is 7. All right, let's do this. Where is our hole located? Right here. 1, 2, 3 at x equals -3. So we're going to find the y value from right and from left. All right, let's do this. We're going to write the limit notation. So the limit as x approach -3 from left, the function of x is the limit as x approach -3 from right, the function of x is. Okay, from left, if we try choose any number going until to the location of the hole, it will more or less approximately it reaches at this point here. So where is it located? 1, 2, 3, 4, 5, -5. Okay, same thing as from right. As it approaches to the hole, it approximately approaches to -5. That means this is our y value, right? You're not asked the coordinate, but when you're asked the coordinate, well, it's easy for you to locate or having the coordinates. Like in this case, right here, if I choose the coordinate, that's 5 and 7. And in this case right here, the coordinate of the hole here is -3 and -5. That's the location. Okay, let's have the third one. As we move on, you are getting used to writing down the limit notation. So I'm going to write down as x approach. Where is the location of the hole in x? Line 1, 2, 3, 4, positive. Okay, from right, what's the function? Limit notation of x as it approach from left. What's the y value or the output value? Okay, this is the left of the hole. This is the right of the hole. So if we choose any number, and then as it approaches to +4, the function is equals to, where is the location here? 1, 2, 3 at -3. Okay. Well, in this case, from right, as any number that we plug in, approximately approaching -3. So same thing, right? Very easy. Just go to the horizontal value to get the x. Go straight. So I do this, going straight. Limit. Where is the location of our hole in x? It's 5, right? So you could start writing the limit as x approach 5 from left. The function of x is what? The limit as x approach 5 from right. The function of x is what? I go straight here where the y value is. So it will be equals to 4. Okay. Let's have this. This is the location of the hole. at -2. Okay, so we can write the limit as x approach -2 from left, and the limit as x approach -2 from right. So this is the left, this is the right here. But as we move on, it goes closer to 2 right there. Same thing from right. As it goes closer, it will approximately have the value of y is 2. Let's have the figure right here. All right. We have 2 holes. So we have to make 2 limit notation here. I'll start with this one. It's located at x equals -6. So the limit as x approach -6, what is our function here? It's 0, right? Left and right, going from left. So this is from left. The limit as x approach -6 from right, the function is still equals to 0. Well, in this case right here, x is 6. So you see it's already noted there as the limit as x approaches +6 from left, the function is equals to 6. The limit as x approaches 6 on the positive side, the function is equals to 6. Okay? All right, let's move on to the next number here. All right, use the graph of the rational function f for the following. We are given a graph. Okay, the graph is at the right side. Right here. I have to bring this up. Okay. F of 6. That means the input is 6. So where are we going to look that? In the x line. So let's say 6 is right here. The input is 6. So what will be the output if the input is 6? Let's look at this and cross over the graph and go straight to the y line to find the output. Here, output. Remember, this is input. Okay. So f of x is equals to 6. We can put the point right there per that location. Next, what is next here? I could see f of 2. What happened in f of 2 here? When x is 2. Okay. We can see a vertical asymptotes. A vertical asymptote here. It is drawn. It is shown. That is a vertical asymptote. Right? At 2. So, what is our vertical asymptote here? We don't get any information so long as we know that it's a vertical asymptote. So that means it does not exist. Right? If you don't. Okay. This is limit x, and then there is from right and from left notation there. From right, and from left. So negative 5. Let's look at negative 5. Oh, negative 5 is where the location of the hole. So we have a hole here, and it goes to 2. The y value approach to 2. Same thing with when from right or left, right, it's still approaching to 2. Okay. 5. The limit of x2 from left and from right. So we are talking about the asymptote here. Okay. So from the left of 2, right here, on the right, this is positive infinity. This is negative infinity. So the function of x is negative infinity from left, and from right it's positive infinity. The limit as x approaches negative infinity, what do we have? A negative as x approach from negative infinity, we have, look at that direction of the graph, positive infinity. From right, you have the direction of the graph, positive infinity as well. Okay, so the domain, what do we have here? Negative 5, we have 2, we have 6. And this is negative infinity and positive infinity. So we have 3 sets of interval for the domain. So we have from negative infinity to negative 5, union with from negative 5 to 2, union with from 2 to infinity. All right, and that is the domain. All right, let's do this. The function is given by f of x equals x squared minus 9 over x squared plus 8x plus 15. Okay, we'll try to factor out. X squared is the difference of 2 squared. So that will be x plus 3 and x minus 3. And the denominator is 15, can be factored out 3 and 5. Right? Okay. So we have a hole there. The hole is located at negative 3. Okay. So which of the following? There is a hole at 5? No. There is a hole at negative 5? No. There is a hole at 3? No. There is a hole at negative 3. We found it. All right. Very easy. All right. Once you know, it's very easy. Use the graph of f. So which of the following could be an expression of the function? So the only information that I think we can get it right away, go straight to the hole. So the hole is located at, okay, I have to blow this up, x equals 4. Okay, so that means that's coming from, because our choices are in terms of expression, so we could find the, that factor. It comes from when x is minus 4 equals 0. So it should be x minus 4 to have a whole of x equals 4. So if we try to look at our choices here, okay, in A, we have an x minus 4. In B, no. So we can eliminate right away. In C, we have x minus 4 in C, in the denominator. While in D, we have no x minus 4. So it's either the A or the C. So what do you think? Do we have zeros? Let's look for the zeros. -2. Okay? So in number 1, we have a 0 of -2, but that's a whole. In letter A, that's a whole. So in other words, we can have the answer right away in letter D. Okay, so x plus 2, that is x minus 2, that is the x-intercept. All right, so that would be, so there is a whole at x equals 4. So the factor is x minus 4. I have it there. So x negative 2, x equals -2 is a 0. So the factor for that is x plus 2. So we have that, we have that, we have this. Okay. All right, let's go to the last one. From the graph, which of the following must be true? Okay, let's look at that. F of 2 is 0. F of 2, the function when f is 2, okay, this is no, because f of 2 here is right here. Up. No, f of 2 is right here, which is equals to 4. Okay, so f of 2 is equals to 4. Not that. The limit of x equals 4 from right, x equals 4 from right is positive infinity from right. No, it's no, because the limit of 4 from right as it approaches to, since we have a hole there, as it approaches to 6. Okay. In C, the limit of x to the right, from right of 4 is f of 3. F of, okay, let's look at this. At 4. Limit of x at 4 from right is 6. And limit of f3, oh, it's 3 of times the function of 0. F of 0. Where is f of 0? Is equals to 2. Right? So if you have 3 times the f of 0, that would be 3 times 2 is equals to 6. So both have the function of 6 for that. Okay, when the function is, it's 2 right here. So this is the answer. F of 2 of f of negative 2 is 0 plus f of 0 is 2. The answer is 2, so it's no. Okay, it's no. So our answer is C. All right. So today we did problems and solutions of holes, and we'll have a lot of this: holes, vertical, asymptote, horizontal, discontinuities, and x-intercept and y-intercept. I'll do a video of that, where in one one graph you will identify all of those. Okay, so let me say this. If I can do it, so can you. Okay, don't forget to hit the like and hit the subscribe button if you don't, or if you haven't yet. See you in my next video.